We're back. In the time it's taken me to pause the video and reset the video, you'll see this update has occurred. So I can update things. That's a ridiculous title. The point is, as you change things in the spreadsheet, everything will be reflected here. You have the option of updating it. So what's next in this gargantuan homework assignment? We have another table to fill in. So we're going to create linear models. This is actually really easy to do. So we have our graph right here. And let's go ahead and edit the chart. And move this over so you can see. Go to Customize, which is where you'll be able to change your titles and stuff. Go under Series. I want a trend line. And I'll do all of them at the same time. We're doing linear for all of them to start. And then label. I want the equation. And that'll do it for us. So now, what you can see is the same color. So for blue dots, which is the cost of a 4-year public education over time, there's a blue square here, this light blue line, which is the trend line, and this is the equation. All right, so this would be the slope. So for example, where we cost of a 4-year public education, the slope would be $377 per year. Right? Our data is incrementing by years, so we'd have 377, or this way, 377 per year. And an interpretation would be that each year, well, not tuition, but just cost, the cost increases by $377. That's all you need. This is really short. And of course, this isn't the case all the time. The linear model is approximating the data. So on average, that's the increase that we're seeing. And you can see a range of different slopes here. And some of them are pretty reasonable. Right? That's not a bad fit. And then of course, this is horrible. This features all kinds of fluctuations. But we're doing what we can with the tools that we have. Now, this is pretty well mashed together. There's not a lot you can do with this. You can do a little bit. I mean, you could stretch the graph out if you wanted to see a bit more what was happening. But it is pretty hard to see what's going on here. That's just the nature of things, or the nature of my small screen anyway. So we have a lot of data in here, and we're trying to see how things compare to each other. So all those equations are there. I'm not asking you about the y-intercepts here, and I'm not, because we're just using the actual year. So the y-intercepts would take place thousands of years ago, before any 4-year institutions existed. So anyway, that's how you fill out that table. And what's next? Right, so what do I want you to do here? So, you know, you shouldn't put all this stuff in. You should delete a lot of this. So what we'll be doing is something like this. We want the rate of increase of a 4-year public education, which we know was $377 per year, versus all 4 methods of measuring income. What do those look like? Well, one of them, right, so we can go down here, annual wages has a slope of $879. Right, so we can say, let's get that thing written down. So as an example would be, we could say something like the rate of change of cost of a 4-year public college is, you know, $377 per year versus the rate of change of annual wages as derived from median hourly wages of which was I think 879. Yeah, 879. And so in particular, I'm looking for some division here. All right. So the ratio is whatever, 377 to 879. What does that end up being? 377 to 879. That's 0.42, 0.423 maybe. So 0.42. So let's take all this information and do something with it. 0.42 times 100 is 42%. So we might say something like this. The cost of the rate of change of the cost of a 4-year public institution is only 42% of the rate of change of annual wages as derived from median hourly wages. So, yeah, that would be good. So that would be the sentence I would keep. I would get rid of all this stuff. Right? So this might be one bullet point. Right? So all the other stuff I wrote was just kind of scratch work, if you will, thinking out loud. And then you could do this again. You could go back and, again, it's the same rate of change for the public institution. What about another one? Annual real median, that's 161. So versus 161 per year. Well, now you have a different ratio. 377 divided by 161 is 2.3. So the ratio is 2.3. So what is that? Well, 2.3 times 100 is 230%, or 130% more. So you could say something like the rate of change of the cost of a 4-year public institution is 130% greater than the rate of change of, what was that thing again? Real median household income. Real median household income. So that might be another example of the statement. And I'm going to delete that. All right. So already we're seeing a great disparity in the sort of statements that we can make based upon data. We haven't manipulated the data in any way. Depending on how we're measuring change in income, we can get quite a bit here. Maybe college is not increasing so quickly. Maybe it's increasing much, much faster than the rate of change of household median income. So you have two more statements to do here. So I'll leave those for you to do. But that's the idea. You saw the scratch work that I did, and then I turned that scratch work into a complete sentence. So, all right. So that's one way of doing it. Again, you could do this in a table if you wanted to. And then at the end, just give a little summarizing statement about the smallest and largest ratios. Okay? All right, what do we have next here? So, and once you answer all this stuff, you can nicely just delete all of this. You don't need all my text in there. Save you some ink. All right. What's next? Question 6. Rank from smallest to largest. That's going to be pretty easy. So you just go down through here and find out, make an order. What's the smallest here? Real median household income. What's the largest? Annual wages. So then make some summarizing statement about which one's changing fastest and which one's changing slowest. The material coming now involves exponential models. So I'm going to pause this video and then do that video. Okay?